Mr. Nichols, Al Bielek, and myself are here to lecture on the Philadelphia Experiment and to go into delta T functions and a delta T generator. We're going to start out by having Al Bielek describe his experiences in the Philadelphia Experiment. Al Bielek, who is a retired consultant engineer, is one of the survivors from the Eldridge. He's one of the two men that jumped overboard and ended up in Montauk in 1983. Once Al finishes that, then I will be back to discuss with you the time equations and how to generate a time stress system. And then I will then be discussing the transistor, the delta time transistor, and then we go into the device that I built and that Al has tested. Then Al will discuss what he tested and what he found the device do. So for the Tesla Society, here is Al Bielek.
Thank you, Preston. The Philadelphia Experiment, so named because of the fact that in the final days of the testing that took place in the Philadelphia harbor, actually started out much earlier than those days of 1943. It began in 1931 far from Philadelphia or the Institute of Advanced Study in a windy city called Chicago, which was in 1931, and several people got together to do a paper study, what today we call a feasibility study, of whether or not you can make an object invisible. Those people were Dr. Nikola Tesla, Dr. John Hutchinson, who was then Dean of the University of Chicago Engineering Section, and a staff physicist by the name of Dr. Emil Kurtenauer. These three people did what today we call a feasibility study. What do you do to make an object invisible? How do you approach it? And all of that sort of thing. They didn't get very far at first, and it was nothing more than a paper study. And about 1934, the project was transferred to the Institute of Advanced Study in Princeton, New Jersey. But prior to that, in 1933, it's important to note that the then new president of the United States, Franklin Delano Roosevelt, he was elected in 1932 and took office 20 March 1933. In those days, it was the 20th of March when they were inaugurated rather than, as today, the 20th of January. He already knew Nikola Tesla from prior contact going back to World War I, when he, Franklin Delano, was Undersecretary of the Navy, and had asked Dr. Tesla to do some government work and the war effort, which Tesla readily agreed to. So in 1933, Roosevelt invited Tesla to Washington after he was president and in office, in exchange of amenities, my old friend Nikola, what have you been doing, and this sort of thing. And he knew about the project that he was already working on and asked him if he would like to be the director of the project. Franklin Delano had unlimited faith in the capability of Tesla to accomplish anything he put his mind to. Up to that point, Tesla had an impeccable, perfect track record. He never failed, and this was well known. Tesla said, I accept, and of course he went on with the program. Now in 1933, the Institute of Advanced Study came online. It had been in the mill for some time prior to that, and 4 principals were brought on board as the original complement of scientists, PhDs, all of them, who became the staff of the Institute of Advanced Study. Now I might point out that the Institute of Advanced Study was on Princeton property, but was not connected with the university itself. The only connection was the fact that it was on university property. It was a totally separate entity. The original 4 physicists, mathematicians, and so forth who came on board was a Dr. Alexander, of which I know very little, some man who I think everybody's heard of, Dr. Albert Einstein, Dr. John von Neumann, and a Dr. Oswald Veblen. They were the 4 original staff members in 1933. Now, in 1934, the project was transferred to the Institute of Advanced Study for continuing work, and it was still a study program which had some Navy funding attached to it from the Office of Naval Engineering. Now, in those days, what we today call the Office of Naval Research was called the Office of Naval Engineering, and that name change took place in 1946. So the project went on, there was more paper studies, and they built some equipment. And in 1936, they had their first field test, as you will. They tested in one of the little wooden buildings they had on the property, which if something went wrong and they lost the building, was no great loss. The equipment worked partially. It was not fully successful, but it gave them encouragement. It told them at least they were working in the right direction to achieve what they wanted. So they continued on from that point with more Navy money and some more staff members, and they continued onward with this until 1940. Now, in 1940, they had a fully successful test which took place at the Brooklyn Navy Yard, in which the vehicle was a U.S. Navy tender, approximately 250 tons. And this vehicle had two other vehicles, ships, adjacent to it, one on starboard and one on port, in which most of the heavy equipment was located. And the equipment which directly produced invisibility was on the tender and on long cables. In case something went wrong, they could cut the cables, and if it got totally out of hand, they could sink the ship. And those precautions were unnecessary. The test was fully successful. The ship became optically invisible, invisible to the eye and to a camera. Well, the Navy was elated. Roosevelt was elated. And immediately, of course, the Navy classified the project. From that point on, instead of being a civilian project under control of the university, it was an rainbow. At that point, of course, all the personnel connected with it had to get a classification, get their appropriate clearances. Offices were set up in the Philadelphia Navy Yard to handle the classified end of the work and the work at the Navy Yard. And of course, other research, R&D, continued onward at the Institute of Advanced Study itself in Princeton. Now, there's a number of things need to be brought in here. What was the background of some of the people involved in this project? Who was involved with the project? And where did the science and technology come from that made this project possible? Because it was successful. One has to go back quite a ways. The first man of importance, we need to look at his history at least to a certain degree, was Nikola Tesla. He was born in 1856 in Smiljan, Croatia, now part of war-torn Hungary. He was a son of poor parents. His father was a priest. His mother was illiterate, but had some inventive skills in developing things for use around the house. Nikola had an older brother, and this older brother was apparently very much loved by young Nikola. And at the age of 7, Nikola's age of 7, the older brother was killed in a horse accident. Set upset Nikola no end for a number of months. But he continued onward. He continued to show an interest in scientific matters, which totally disturbed his father, because his father was determined that Nikola was going to follow in his footsteps as a priest. Well, some years later, in his early teens, Nikola became very ill, actually violently ill, and he was in bed. They expected him to die. And his father finally says, "All right, Nikola, if you really want to go to engineering school, I'll consent and let you go to engineering school." Nikola recovered almost immediately and quite miraculously from his illness, finished his high school in Europe. In those days and today, they called it the gymnasium, which is their term for the high school, and enrolled in the university in 1878. He was there 1 year, formally enrolled, when his father died, and that left him without any funds. So Nikola at that point had to go to work for a living, and he first took a job with the telephone company in Budapest, where he was at for about 2 years. He tried to continue his studies on the side, but he did not have the funds to pay the tuitional fees, and consequently all he could do was monitor some of the classes. In 1882, he went to Paris and went to work for the Continental Edison Works. And after many arguments with his professors over a period of time about AC theory, which he had already developed, he had the concepts in mind before he came to the United States. And these professors were rather hidebound and didn't believe there was anything to the AC theories, which Tesla espoused. So Tesla decided he needed greener pastures, and he decided to emigrate to the United States in 1884. At that time, he prepared himself. He had luggage and all of the usual things, and on the process of getting to London and aboard the ship His luggage was lost, and he arrived in New York at Ellis Island with 4 cents in his pocket, a book of poetry which he had written, a command of some 11 languages. He was a prodigious reader and learner, and most important of all, perhaps, was his letter of introduction to Thomas Alva Edison from the works manager of the Edison Company in Paris. So eventually Tesla, after he was in the U.S., found Edison, was introduced to him, and Edison asked him what he did, what he had to offer, and immediately got into a discussion about power systems, AC power versus DC. Edison, in case the people who are viewing this tape and here also in the audience did not know, Edison was a DC man. Tesla was totally sold on AC, and of course Tesla was convinced that AC was the wave of the future and the only way to go, and Edison was totally against it. Nonetheless, in spite of these initial arguments, Edison told him to report to work the next morning. He says, "I need all the good brains I can find, and you obviously have a good brain. You're well recommended by my works manager." Tesla worked for Edison approximately 6 months, and in that period, he was given a specific assignment by Edison to try and correct some problems, and was told that if he finished successfully this problem and solved it within the time period assigned, that he, Nikola, would receive a bonus from Edison of some $50,000. Tesla finished the project in time. The project actually was to stop the arcing of brushes on some DC motors. Finished the project in time to Edison's satisfaction, and then asked Edison for the $50,000 bonus. Edison more or less laughed at him and says, "Well, you don't really appreciate the American sense of humor." Tesla said, "I most certainly do not," and walked out and went back to ditch digging. Shortly after that, Tesla was picked up by the then president of Western Union Company, who had heard of Tesla's reputation, and decided that he was going to support him, handed him a check for some $35,000 to build a lab and start work on building his AC motors and generators. Now, at the same time, 1884, when Tesla arrived in the United States, the Institute of Electrical Engineers was formed in New York. And it has, as I have checked in the files and records, all of the notes of all of the lectures and all of the meetings all the way back to day one. And Tesla was a very popular lecturer at that Institute of Electrical Engineers. He used to lecture on a most regular basis, and in the contents of his work, he eventually decided and was given permission to demonstrate an AC generator system and how it would light the lighting in the hall as compared with the DC. It was rather an instantaneous success, and one of the men in the audience was George Westinghouse, founder and president of Westinghouse Air Brake Corporation. Westinghouse was very interested in what Tesla was doing, took him to dinner at the Waldorf Astoria, and over dinner they worked out an agreement where Tesla would be paid $1 million cash for all of his 20 patents, which were then issued in the United States, and a $1 per horsepower royalty for every horsepower of engine, motor, or generator which was produced. This gave Tesla a great deal of working capital and the means to go on to other things which he wanted to do. So in the results of that lecture, he had his laboratory, he had financial backing, and in the interim period between his arrival in New York and at that time through Edison, he met a rather important person, J. Pierpont Morgan. Morgan was a well-known financier. He was interested in far-out projects, and if he thought it would go, it was worthwhile, he would invest his money in it for the intent, of course, of making money. He was introduced to Tesla, and of course he had his own particular little spies and informers, if you will. He knew a great deal about Tesla even before he was introduced to him, about his eccentricities, what he was interested in, and his AC theories. As a consequence of that initial meeting, of course, J.P. Morgan backed him, and this continued for a considerable period of time. Now, in 1889, there was a contest initiated to see who would build the power equipment for a new large hydroelectric power station to be built in the United States at Niagara Falls. Tesla won that contract, much to the disdain of Edison, who wanted it very badly. And of course, Tesla built the equipment, it was installed, and the Niagara Falls Power Company went online about 1894, transmitting power via transmission lines to Buffalo, New York, a distance of about 35 miles. Quite an accomplishment in those days, but of course nothing of unusual note today, because we have a power grid all over the United States and Canada, and these power grids are basically all over the world. Old hat, we would say to us today, but it was a major breakthrough at that time. Additionally, Tesla took out his citizenship papers and became a U.S. citizen in 1889, 5 years after his arrival. And in 1893, there was a major centennial exposition in Chicago, the 1893 World's Fair. Tesla won the contract to provide the power for that World's Fair, which he did. And he also demonstrated at the World's Fair for the first time two-way radio transmission, a radio transmitter and receiver. A completely new device, unheard of at that time. In 1898, at Madison Square Garden, he demonstrated something further, a radio-controlled model boat, and a special boat built for him in Madison Square Garden. In 1889, he went to Colorado Springs with Morgan's blessings, I might add, to do some very basic research, build his famous laboratory and towers, of which there are pictures extant around the society and out in the lobby, and which he wanted to do basic research for 2 years, 1889 and 1900. He did this work. Among other things, he generated 200-foot-long lightning bolts, a feat not duplicated to this day, built a huge Tesla machine, did a lot of research, and among those things which he did, he demonstrated the feasibility of transmitting electrical power without wires over a distance of 26 miles to light some rather sizable electric light bulbs. When he finished with his work there, he held a press conference. He announced what he had done, some of his findings, and that, among other things, he had received strange radio signals from some strange place which he assumed was off-planet. This made great press for the newspapers, but was taken with rather a dim view by his scientific colleagues. Nonetheless, he went on. He went back to J.P. Morgan, told them, I can demonstrate to you the transmission of sound and pictures through the air, what today, of course, we call radio and television. And J.P. Morgan's eyes allegedly lit up, and he told Tesla, if you can do this for me, he said, you can have all the money you want. So that began the construction of the Wharton Cliff Tower on Long Island. The project begun in 1901 with the intention of demonstrating long-range transmission of radio signals and eventually television. Now, there was an international contest afoot worldwide to see who would be the first to cross the Atlantic, span the Atlantic with radio signals from Europe to the North American continent, at least to the position of Newfoundland, which was where it was successfully transmitted by Marconi in 1902. Marconi, it must be added, had been in Tesla's laboratories back in the 1890s, and at Tesla's invite, he had open sesame to all of his files, and probably learned a great deal about radio from him. Marconi made his announcement of being the first to transmit across the Atlantic, claimed the prize, and of course J.P. Morgan lost some interest at that point in Tesla because Tesla did not succeed in being the first. Tesla had $100,000 from J.P. Morgan to build this tower, and that funding was completed. The tower was not complete. Tesla did complete it with his own money, but did not have enough funds in order to complete the installation of all of the equipment that was required. The tower was never used. It stood vacant until 1917, and because of indebtedness, Tesla sold the tower to Waldorf Astoria Hotel System, and in 1917 they tore it down. The laboratory building that sits next to the location where the tower was is still there intact, the one used today. And the underground installations, which had originally a wooden staircase going down some 60 feet into some underground installations which are part of the tower, probably ground plane connections. The underground facilities are still there, but nobody can go into them today because the stairwells have long since collapsed. The stairways are gone. In any case, Tesla continued during that period of time doing a lot of R&D, and at that point where he announced that he wanted to go to wireless transmission of power, he slowly, but most methodically, was reduced into a non-person. He was erased from the textbooks, He was no longer announced with a great heraldry, which he had been socially accepted all over the country previously, and slowly slid into the position of a non-entity and a non-person. You might say did not slide. He was pushed, gently but firmly. In 1917, Tesla was working for the American Marconi Company when he was approached, probably for the first time, by Franklin Delano Roosevelt, then Under Secretary of the Navy, asked if he would do some work for the government, for the war effort. Tesla had readily agreed and said that he'd be happy to do so, and he became employed by the government. And at about the same time, the American Marconi Company was dismantled by the government as a possible hotbed of spies and saboteurs. In 1919, this organization, now defunct, was reorganized into a new operation called RCA, Radio Corporation of America. It went online operational in December of 1919, and most of the engineers from the American Marconi Company, including Tesla, became part and parcel of RCA. Tesla went on board as an engineer and remained with the organization for many years. Eventually became chief engineer, and in 1935 he was promoted to the position of vice president and director of engineering and research worldwide, a position he held for 4 years until 1939, when he was given his retirement party at Cherry Hill, New Jersey. The government doesn't really want anybody to know much about this, that he was at RCA for 20 years, and you will find little or no references to it today out in the open literature. Basically, zero references. But this was during the period when he was supposed to be a recluse, living in his little New Yorker hotel room doing nothing. He went on and did many things. In 1931, among other things, aside from the Project Invisibility, he developed and demonstrated wireless power to run an automobile. He converted a Pierce Arrow, took out the gasoline engine, put in an electric engine, allegedly 75 horsepower, developed a black box with tubes in it. That's all anybody knew that was in it, approximately so square, put it in the dashboard of the car when he wanted to go somewheres. And he would drive all over Manhattan and eventually all over New York State, much to the interest and encouragement of the newspapers and to certain people who witnessed it. Nobody knows for sure what happened to the car, but this was in the press for a considerable period of time. In 1935, he developed a particle beam weapon system, which he attempted to sell to various nations, the U.S., Britain, and Canada. They all turned him down. When the Russians were offered the system, they bought it for $25,000 cash and a working model. Not a full-size one, but a working model. And the records of this were lost during World War II. I have a friend in Phoenix who investigated this and verified through the Russian embassy that, yes, there was such a contract. Yes, Tesla did deliver a model, but it was destroyed during the war years, and we don't really know what happened to it or any of the other information. At least that's what was said. In 1938, approximately, Tesla also developed a death ray system, separate from the particle beam weapon system. This death ray system basically was a laser device, laser-like, with a barrel about 18 inches in diameter and about 4 feet long. It was mounted on top of a specially built tower at White Sands Proving Grounds. And all of the charging capacitors and other power equipment was in this tower, which was quite extensive and heavy. And the target would be put out within range of this device. Basically, they would use an Army truck or an Army tank. They would charge up the capacitor bank, and when they were ready, it would fire much like a pulsed laser, emitting a green light, which would come onto this target, and the tank or the truck or whatever it was would disappear. They even tried it on animals. They all disappeared, not invisibly, but permanently. Later, it was tried on the mountaintop there at New Mexico, and allegedly it bored a hole through the mountaintop, which became just a little too much for the military. The stories I've had are that they became rather terrified with this weapon and decided, after some consultations, to destroy the model and bury the records of what had been done and of the technology behind it. I find it hard to believe that the government would bury completely such a project, but that is the information I have. This was all during the period when Tesla was allegedly a recluse. In between all of this, he was still working on Project Invisibility. Now, in 1940, after much more research, a fully successful test was engaged And this was on a small Navy ship, a tender, in the Brooklyn Navy Yard. And there were two ships involved with that test vehicle, one ship on starboard and the other on port side, which held most of the heavy equipment. And through long cables, the actual hardware to produce the invisibility was on the target ship, the tender. No one was on board that experimental ship during the tests, which is quite important. And when they turned on the equipment, the ship became invisible, totally optically invisible, both to eye and to camera. And of course the Navy was elated. They said, we have finally a successful test. And of course Roosevelt was satisfied, and what did the Navy do? They immediately classified the project, called it Project Rainbow, set up classified offices in the Philadelphia Navy Yard on the top of a building, of which I have slides and we'll show you later. And everyone had to be properly cleared and get their clearance papers and so forth. Research continued at the Institute, but the Navy's part in this, now taking over the project, was run basically from the Philadelphia Navy Yard. There are other people in the background who I should give some sketch work, some small rundown biographically of what their contributions were. Not only was it Nikola Tesla, but there are other people who made major contributions and set the groundwork up for the mathematical and scientific background making this achievement possible. The second man I should go into in his history, I was born in 1863, and that was Dr. David Hilbert, a German mathematician born in Germany, 1863. Got his degree in mathematics, taught in the PhD mathematics degree, taught in the German university system until 1930, retired, and eventually died in 1943. He developed 5 systems of mathematics. The only one which we are concerned with here is the last of those 5, which was sometimes and is usually called Hilbert space, a mathematical means for describing multiple realities. Now, that period of work, which encompassed a number of years, overlapped the period when other people concerned with this project were also in Germany. Now, in 1879, another very important man, I think everybody's heard the name, Albert Einstein, was born in Ulm, Germany. I won't go into his history other than to state that he acquired his PhD in mathematics in the years after the turn of the century. And he worked in the patent office. And he issued his so-called special theory of relativity about 1907, then the general theory of relativity in 1915, at which time he had offers from virtually every university in Europe to come to that university and lecture. He did lecture throughout the German university system until 1930. And at that time, his friends told him, take a look at what's happening here in Germany, and you should be able to see what's going to happen in the near future. It's not wise for you to stay here in Germany. You should leave. Well, they did smuggle him out. As I understand it, the National Socialist Party, of course that was the party of the Third Reich, did not want him to leave. They considered him a national asset, but his friends smuggled him out, brought him to the United States, and he was teaching in California at the Pasadena University, well known as Caltech, and also resided in Pasadena. A friend of mine, now deceased, I've met him there more than once and knew that he was there, and told me about Einstein's 3-year tenure at Caltech until 1933, which at that time when he told me didn't really mean that much to me. But in view of all of the other events since, now has much more meaning. In 1933, he was made an offer to come to the Institute, which he accepted, and he remained there until his death in 1955. The next man of importance was Dr. John von Neumann, born in 1903 in Budapest, Hungary, the son of a rich Jewish banker. He had 2 brothers and a sister. He was almost a genius from birth. He was capable of adding up or multiplying in his head 2 strings of 8 numbers and coming out with a correct answer in his head at the age of 8. A prodigious accomplishment. He took his time getting his education, however. He was in no great rush. Eventually decided he wanted some backup profession, if you will. Took a degree, a bachelor's degree in chemistry in 1925. In 1926, his PhD in mathematics. And he, Dr. von Neumann, also taught in the German university system for 4 years until 1930. During that period, he also met Dr. Hilbert, whom he interfaced with to a great degree, wrote a paper in German on some of Hilbert's work, studied it, and eventually decided to leave for the United States, but not before he met Dr. Robert Oppenheimer, who was also in Germany at that time. Oppenheimer did not figure at all in terms of this project, but of course was in charge of the Manhattan Project, the atomic bomb project during World War II, which became important to Dr. von Neumann after the Philadelphia Experiment project collapsed. Von Neumann came to the United States in 1930, taught at the Princeton University Graduate School as an adjunct professor. And in 1933, he was made an offer to come to the Institute, an offer he accepted, and was on staff there for many years. Now, in 1909, another very important man to this entire project was born. It's a Dr. Norman Levinson. I can find out very little about him, but I have determined and found from some of his works, he published some 5 books. He was a mathematician, American-born, an assistant professor of mathematics at MIT until 1955, and a full professor of mathematics from 1955 till his death in approximately 1976. There are 5 books in the open literature, which can be located if you search diligently enough. And the most important work, however, was classified, and that is the work he did on the time equations and the time matrix. Absolutely essential to understanding what was being done or was about to be done at the Institute to produce the invisible or invisibility effect, the cloaking, if you will. One other man was rather important to this project, T. Townsend Brown, born in 1912, I believe, in Zanesville, Ohio. He had a fairly checkered career, eventually acquired a degree in engineering, bachelor's degree, and in the Depression years could not obtain much in the way of employment. He enlisted in the Navy with his degree as an officer in the reserve status. And in 1938, he was tapped on the shoulder by the Navy, saying, "You're in the Navy now, and we even have a department for you to head up. It's minesweeping, and we want you to develop some new procedures." The first major problem they handed him was how to cope with the newly developed German magnetic mine. Now, unlike the ordinary mine, which has large spikes on the end of the mine and is floated at a given depth below the surface, contact, direct physical contact, would cause the mine to explode. The new ones were different. They sensed the magnetic field of the Earth, and when they sensed a concentration of magnetic flux due to the approach of a large iron or steel vessel, the internal sensors to this device would say to the mine, a ship is overhead, now is the time to blow up. And would blow up and essentially blow a hole through the bottom of the ship. D. Townsend Brown was given the task of finding a means to explode these devices safely at a distance. And he eventually developed a system that was very similar in many respects to the work which followed on the Invisibility Project, but was not the same. He developed a system of wrapping coils around the hull of a ship. They were driven by very high current pulses from a special generator aboard the ship, and these current pulses through the coil would generate a magnetic field, pulsed, which would extend to a sufficient distance that the magnetic mine would sense a ship was near and blow up at a safe distance, quite safe from damaging the ship's hull. T. Townsend Brown also did make other contributions to the project. He made and designed a special antenna because he was an RF expert, and a special quadriphase antenna mounted on the highest point of the ship, that is the Eldridge, DE-173, in the tests which were conducted on the Eldridge. Now, this only gives a thumbnail sketch. There's much more to be said about these people, but it does show some of the background. And it is important to understand the background of the contributions here in order to grasp what they were really doing. Now, in 1940, I came on board the project, and you might well ask, how did I come on board? How did I become part of it? I was not born Alfred Bielek. I was born Edward Cameron, son of Alexander Duncan Cameron, Sr., 4 August 1916, Bayshore, Long Island, and father at that time was himself a Navy man. He was born in 1891 and died in 1981, 90 years later. He did not, so far as we know, acquire a college education, attended Loyola School in New York, and joined the Navy at some time which we cannot determine because all of those records have disappeared from the family files. I assume from what I can piece together about 1910. We have one photograph of him as being in the Navy and taken in 1917, showing him in his uniform as a bosun's mate first class, and that's in my slide collection, which I will show later. Now, he was a rather prodigious ladies' man, and he acquired a girlfriend, if you will, a live-in woman. I was born of that woman at Bayshore, Long Island in 1916, and Brother Duncan, literally a half-brother, by the other woman he was keeping, was in Connecticut, and he was born in 1917, May, if I remember correctly. And of course, in 1917, we were dragged into the war in Europe, and the Navy tapped Father on the shoulder and said, "The war's on. You're going to sea at this point." And of course, he was in the Navy. He went to sea, abandoning both wives. And of course, Duncan and I were then left sort of on our own, but since the rest of the family knew what was going on, we were picked up by Auntie Arnold, and we were raised in a big house on Long Island in Islip. So it was a transfer for me from Bayshore, Long Island, to Islip, and for Duncan from Connecticut. Father himself had been raised by Auntie Arnold because my grandfather, his father, died of a gunshot or a gun wound accident in 1896. So he was in turn raised by Auntie Arnold. So we grew up, went through our high school years, and Father, who visited us typically once a year, usually around Christmas for about 2 weeks, insisted that we get a good education. The family had no lack of money, because the Arnold was of the Arnold Constable Company in New York, a department store chain, which was doing very well. There was a great deal of money in the family. So when we finished our normal high school and schoolwork there, we went to university. I chose to go to Princeton, and Duncan, for whatever reason, chose to go to the University of Edinburgh at Edinburgh, Scotland. He went through the whole 9 yards of his schooling there and took a degree in physics, a PhD, in the summer of '39. And I went through bachelor's and master's at Princeton, and I met at that time Dr. John Van Neumann, who took a great interest in me, and I did not understand why then. That awareness and understanding came very much later. Well, after both the Philadelphia Experiment and the Phoenix projects were over, I finally learned why. But in any case, he suggested it would be much better for me to go to Harvard to get my PhD in physics. It was a better school, etc. So I did. I transferred and took a PhD in the summer of '39 at Harvard. Come September, Father arranged for us to join the Navy. We enlisted in the Navy at 50 Church Street, New York in September. We both took commissions, Lieutenant J.G., went to a 90-day wonder school in the Navy's collection of 90-day wonder schools up in Providence, if I remember correctly. And after that was over, we were assigned to a project. That school was maintained for officers who enlist with an education who were to be assigned to a special project. So we were assigned to our special project. We didn't know what we were going into or what to expect. Father, of course, already knew, I'm certain of that. We wound up at the Institute of Advanced Study at Princeton, New Jersey, part of the Invisibility Project. We thought we knew a great deal about physics. In fact, we thought we knew all about it, as was currently taught. We quickly learned at the Institute that we really didn't know much of anything. The cutting edge of science, of mathematics, and technology at the Institute was decades ahead of what they taught at the school. We learned, for example, that our universe that we live in, the 3 dimensions that we all accept, plus the 4th dimension of time, is hardly a full explanation. There's actually a 5-dimensional universe. There are 2 time dimensions, where we refer to as T1 and T2. I'll get into that later technically. But we learned about that. We learned about the project, what they were attempting to do, how they attempted or were going to make a ship or an object invisible, which involved a manipulation of the time field. We learned that the work here was not totally original. It was in the literature since 1931 about multiple 5-dimensional reality, from the days of P.D. Ouspensky in 1931, who wrote a book entitled Tertium Organum, or A New Model of the Universe. Well, we were brought up to speed. We became part of the project, and of course, approximately September, the successful test, everything was classified. We obtained our clearances, and we continued on with the project. Many things happened from that point on. After the project was classified, of course, the Navy was elated. Roosevelt was elated. And of course, Roosevelt then, knowing Tesla and his impeccable track record, decided that he wanted to give him a somewhat larger ship to work on. He gave him a battleship and told Tesla, if you can make a battleship invisible, you can make anything invisible. So this battleship was tied up in the Philadelphia Navy Yard in the back classified section, and work proceeded on this ship to get it ready for the tests which would have come much later. So at that point, of course, Tesla had to order equipment for a much higher power level than was used on the tender. Well, this work continued on, and we were with it until January of 1941. In January of 1941, the Navy decided that we had to go into the Navy at sea, and as officers, we had to learn what the Navy was all about. So we were assigned to a ship, the USS Pennsylvania, which went out in the Pacific, and we roamed all over the Pacific for the better part of a year. And we came into Pearl Harbor in October of 1941. The ship went into dry dock, and we took leave and went on to San Francisco. I'll get into the slides in a little bit. With this battleship, he expected, of course, that Tesla would make it invisible and prove his principles. So Tesla went to work and proceeded to order equipment, do his design work, and get the battleship ready. Now, they did not tear their ship apart. It was parked in the harbor of Philadelphia Navy Yard, actually the inner harbor, where the classified work was done. And outfitting was eventually done, but something else occurred at the end of 1940. The Navy decides that Duncan and I have to go to sea to learn what the Navy's all about. So you're going to be assigned to sea for a year aboard the USS Pennsylvania, which was a flagship of the fleet, a battleship, built in 1916, commissioned in 16, I mean to say. And we were assigned from January 41. It was to be 1 year on the Pennsylvania, so we roamed all over the Pacific. There's some other anecdotes I won't go into. But nonetheless, comes October of 1941, the Pennsylvania comes into Pearl Harbor and goes into dry dock for overhaul. So we had some free time, and we went to San Francisco on leave. And of course, we had a ball there. And our orders were cut for the return to Pearl Harbor and to the Pennsylvania on December 5th, 1941. December 5th, we were at the airport, the Naval Air Station, about to board the plane, and orders came through from a captain of the Navy who actually came up to us and says, "Gentlemen, your orders are canceled. Come with me." So we followed him to an upstairs floor of the Naval Station. We were met by Hal Bowen Sr., who was then director of the Office of Naval Engineering. He told us, "Gentlemen, we do not want you to go back to Pearl Harbor. We have reason to believe that within 48 to 72 hours, the Japanese are going to attack Pearl Harbor, and you're much too valuable to us to be sent back there. So you're staying here in San Francisco, finish out your tour time with the Pennsylvania, and you can take leave time as you wish, so that you can do some paperwork. But he says, after you return to the Institute, there will be no leave time, and it'll be nothing but hard work, so make the most of it." And we did. January, we returned to the Institute. And of course, December 7th is history. I don't need to go into that. And we then found that in January of 1942, the plans were well advanced and equipment was already built for the test of the battleship, which was slated for March of 42. We were brought up to speed on that, and Tesla was very upset and concerned over the fact that with the amount of electromagnetic power that was required to make a battleship invisible, that he was going to have some very serious problems with personnel. The plan was to have personnel on deck to observe from the deck of the ship what happened and what they could see, and he knew there could be possibly some dead sailors. He had already been advised that this would happen from his, shall we say, radio contacts with the outside, because he was in contact with extraterrestrials from about 1931 onward. That's a separate story, which was really a little too long to go into. But he was advised that there would be a problem, number one, and number two, it was solvable. So he went to the Navy and asked for more time to solve the problem. He says, "I can solve it, and I know there will be one." And of course, they came back with the typical retort during war years, quote, "There's a war on," unquote. "You have a deadline, do what you need to do, but you will meet that deadline." So Tesla was given a rather unpleasant choice, namely, go ahead with the test and hope everything came out all right, or sabotaged the test in some manner so that the sailors and the personnel were not affected. He chose the latter course, and on the morning of the test, when it was scheduled, he saw to it the equipment was not properly tuned, was detuned, and the only thing that happened was a few transmitter bottles blew up, improperly loaded. And, of course, there was no invisibility field. And he says, gentlemen, the test is a failure. I'm bowing out at this point. I have other things to do. And you have a very good man here who can take over, Dr. John von Neumann. So immediately, Dr. von Neumann took over the project. Of course, there is a debate to this day. Did Tesla leave voluntarily, or was he fired by the Navy? We don't know. But in any case, we know he did leave. Von Neumann says, I need time to study this to find out what went wrong. He quickly found out what went wrong. He was no fool, and he knew what Tesla was doing. But he decided to take advantage of the time available to him to do a redesign of the equipment. Now, Tesla was an analog man. This means he believed in continuous waves and continuous modulation waveforms as against what is commonly used today in many communication systems, pulsed mode. He did not believe in it. He did not want to go that route, and he used all analog systems. He had 4 modulating frequencies in the RF transmitters. Now, after I go through the slides, I will get into the theory of what went on with the Eldridge and what they were actually doing. Suffice to say that they had some very powerful equipment to generate a rotating magnetic field and a rotating RF field. The same approach was continued by von Neumann, the same basic theory applied, but von Neumann decided to make it a pulsed approach, meaning that instead of continuous waveforms, he would pulse them at about a 10% duty cycle, both the coils for the magnetic field, which meant pulsing the large generators, as well as the transmitters. RF transmitters, regular radio transmitters, except these were a little bit beyond the standard AM radio transmitter because they were operating at a carrier frequency of 160 megahertz. And with the boosters and the new system that von Neumann developed, they were capable of putting out 2 megawatts each CW. That seems like a lot of power today, but in terms of radar, it is not. And they did have the capability to go beyond 160 megs in those days. The public didn't know it. So von Neumann redesigns everything, and he does a number of other things. He decides he wants a ship which has been designed from the ground up for this project. So he went to the Federal Shipbuilding Yards in Newark, New Jersey, not far away, and with the Navy's approval, picks a number off a drawing board known as DE-173, and is a destroyer escort, approximately 1,540 tons laden from the Navy's official records, and says, I want number 2 gun turret left unfinished. Just leave a hole there. Leave the interior of the ship largely gutted, not completely, and want rails put in the bottom of the hull so that we can drop heavy equipment in and move it to the center of the ship. And when that work was completed and the ship was built, it came down the ways, and in September of 1942, went into dry dock. The heavy generators, 75 kVA each, with a motor drive which was 750 horsepower with 2 right-angle gearboxes, very large, massive equipment. A diesel-electric generator to power this equipment separate from the ship's main power. That diesel-electric generator was something of a monster at 8 megawatts. Rather large and rather heavy. And all of this had to be installed in dry dock. This was all installed. The ship in December went under its own power to the Philadelphia Navy Yard and was put in the back section where they outfitted the rest of the electronics. And this process went on, of course, until everything was in and we started tests in 1943, early 43. But one other item is of interest here, and that is that both von Neumann and the Navy decided we needed a volunteer crew for this operation that was possibly hazardous. So they went throughout the Navy starting in July of 42 and asked for volunteers for a special project, somewhat hazardous perhaps, hazardous duty pay applied, and they got volunteers, approximately 33 enlisted men, and there was 6 or 7 officers. In September of 42, they were trained at the Coast Guard Academy at Wharton, Connecticut, if I remember correctly. And the man who was the, shall we say, the schoolmaster and head of this class, and I have the picture of it to show you, was none other than my father. The class graduated in December of '42, and they were shipped across to the Navy Yard awaiting orders, and they remained there until they were put on board ship. Along about March, after much preliminary testing, Van Neumann, after Duncan and I were talking with him extensively, telling him that Tesla was afraid of problems with the personnel, decides, yes, there might well be a personnel problem. I'm going to see what I can do about this. And he decided to add a third generator to produce a counter field around the main field. Now, we'll have to show this to you on a blackboard after a bit, what this meant, what the theory involved, and what kind of a field they actually generated. For the third generator, they could never synchronize. It took special electronic circuits to synchronize the first two, because with the size of the gearboxes and the mass of those generators, the only way it could be done is by electronic means, and it was accomplished. The third generator never synchronized with the first two, so sometime in May of 1943, a technician who was assigned to us, a man by the name of Jacques Deloire, Jacques Leroy, not Deloire. Deloire is for Deloire Laboratories in England. He was assigned to us as a technician. Sometime in May, that third generator went out of control. It zapped him with a huge charge of energy. He wound up in a coma, went into the hospital, and 4 months later he recovered. He took a medical discharge from the Navy, and he didn't turn up again until a short period of time ago, roughly 2 years ago, and that's part of the latter end of the story. In any case, he was off the project. Van Neumann knew the third generator would not work, so he scrapped it and went back to his original approach, and he was in the position of scratching his head and being a little bit fearful about what might happen. Because you consider the fact that you have 4 RF transmitters, each capable of putting out 2 megawatts continuous wave and pulsed at 10% duty cycle, theoretically capable of 20 megawatts pulse power, peak pulse power each. They didn't go that high, but they had the capability. Plus the rotating magnetic fields. You had a system here which was essentially guaranteed to cause neurological disturbance, if not worse. Up to that point in known history, no one had ever attempted to produce and rotating fields of that power and then deliberately subject personnel to them. But that is what was done. How did that come to pass? After the preliminary sea test for the ship, it was seaworthy. They wanted to be able to go to sea immediately if it worked. They had all tests completed for the preliminary systems and subsystem tests, and they decided on July 20th they were going to have the full-blown test for the Eldridge. With the test crew aboard, and Duncan and I being trained to run the equipment in the hold, and I'll show you where in the hold from the pictures, they scrubbed it till the 22nd for reasons of weather and other factors. And at that time, on the 22nd, they had their tests. The test crew was aboard, and we were given instructions by radio to actually proceed with the test. Now, there were no computers in those days. Consequently, everything had to be done manually. Of course, today we have computers, and you can do it by computer control. No such luxury then. Van Neumann didn't invent the computer till later. So we turned the equipment on, and for about 20 minutes, as observed by the observing team on a neighboring carrier, everything was successful so far as they could tell. The ship became invisible to sight and to radar. And after 20 minutes, the man who was in charge of the test crew and the observer crew, as a Captain Harrison, now deceased, noticed something which he didn't like. He was on the deck of a carrier, which put him an advantage to look down around the size of the ship, or where the ship should have been. And knowing the size of the carrier, he saw a huge waterline, much larger than the ship, and he couldn't find the bottom of that waterline. It was like there was air there, and the ship, though invisible, was probably floating in air, was his conclusion. That was not the truth, but nevertheless, that was his fear. He ordered the demonstration and test cut off at 20 minutes. The ship was returned under its own power with its own crew to dockside, and then we found nothing wrong with the ship, but that we had a personnel problem. Those personnel deliberately stationed on deck to observe what happened while the ship was invisible were all nauseous, disoriented, totally out of it, as we said, and mentally and neurologically very disturbed. So the Navy said not to worry, we have another crew. Of course, the other half of the test crew were volunteer crew. And von Neumann then knew he had a very serious problem. So we all got our heads together and scratched, and what are we going to do? And the Navy says, he asked for more time to study the problem. The Navy said, well, we'll allow that you only have to make the ship radar invisible. We do not need physical invisibility to the eye or the camera, because in those days there were no navigational systems, no satellites, no low-end, no shore-end. They were dependent on either radar or line-of-sight optical viewing of an adjacent ship in a convoy. And if the radar was blocked out, then they had to be able to see where that ship was in a severe storm where they might ram each other in a convoy. It didn't really help much. And a few days later, the Navy comes up with this famous order: you shall complete your test by the 12th of August, 1943, or forget it. That was a drop-dead date, as we called it. And we all scratched our heads. Why? I went to Hal Bowen. I says, what is this all about? And he says, I don't know. I was given the order. I'll see if I can find out some more about it. It came from the actual CNO, Chief of Naval Operations, who was then Admiral King, as an order. But why should he be concerned about an engineering test when he is primarily concerned with the operation of the war and the operation of the fleet in all theaters of operation, European, Pacific, wherever? Nevertheless, he was the authority for this order, and we figured it came from on higher, which it did, but we didn't know that then, and we didn't find this out until many years later, meaning literally after the Montauk project was over, which says in 1986, 87, we finally found out what this meant. Nevertheless, we were stuck with this date. We tried to make modifications, and we did make some as per the Navy's request. And of course, Captain Harrison wanted to make a few tests of his own. Yeah. In view of what that's more like the original, the other one. In view of what he observed of the Eldridge in the first test, namely a very far out water line, and they could not see the bottom where the water line resumed under the ship, he decided to outfit the Eldridge with pressure testing systems and devices, hydrostatic readout devices on both the inside and outside of the hull, a secondary crew to make measurements of the actual hydrostatic pressure and hull pressure, and he had to his command a submarine which would then go under the Eldridge and see where the water really was and what was going on. So we had two crews on board the Eldridge and a submarine available. At the last minute, at the morning of 12 August 1943, some kind of problem developed. Didn't like to call it in the Navy a glitch. And they pulled that secondary crew off the Eldridge, put them on the sub, moved the sub out of the area, and then says, we can go ahead with the test. So naturally, Duncan and I were there scratching our heads and standing by the rail before we got our final orders to proceed, wondering what the blazes was going on. We're very apprehensive. We knew something was wrong, but we had no idea what. We didn't have too long to find out. The orders came about 1000 hours can proceed with the test, so we turned all the equipment on as per the new protocol. And for the first 60 to 70 seconds to the observers on that carrier, as well as two other ships now available, a cutter and a commercial vehicle known as the SS Furiaseth, a merchant marine ship, it appeared to be going normally. The ship was radar invisible, but you could still see it through a haze, a greenish haze, not pink as per the movie. And they were watching the ship in the rotating fields, and what appeared to be something rotating anyway. And all of a sudden there was a blue flash and the ship disappeared, waterline and all. There was no waterline. They knew the ship was gone. And at that point everybody panicked, including Dr. von Neumann. Where is the ship? What happened to it? They could not raise anyone by radio. It returned approximately 4 hours later to the same location in the harbor. And they knew immediately something very bad was wrong, because they could see that the special antenna designed and installed by Townsend Brown for the radio transmitters, it was a special quadriphase antenna, was broken. A piece was missing. There was some minor superficial damage to the ship, and they saw people milling around, almost running around on the deck in a totally incoherent manner, and they could raise no one by radio. So they ordered a launch, and a special